Okay, so we spent last week, specifically Thursday and Friday, talking about determining congruence between two shapes, right? And we decided that in order to determine congruence, then we need to determine congruence between each part, each corresponding part. And we talked about corresponding as corresponding are like things being in the same place, right? So the example that I gave was my room and the room above me, right? My door corresponds to the door in the room above me. It's the same piece, they're in the same location. So each vertex or vertice should correspond to another vertex or vertice each side, each angle corresponding to another side or another angle. Right? So that's all to say that if two things are congruent, then every single piece is congruent to a corresponding piece. Now, the way that we talked about it was I need to prove each piece individually as congruent to each corresponding piece. So if I have a triangle, whoopsies, if I've got a triangle, that's a really bad triangle, but we're going to go with it, then each angle has to be congruent to a corresponding angle, and each side has to be congruent to a corresponding side. Okay? Now, that was maybe a little bit tedious, and it took a while, and it actually turns out that there are some shortcuts that we have that will allow me to prove congruence without necessarily proving every single side and every single angle. Okay? And so the first one we talk about is side angle side, or SAS. SAS. Okay, and so that order is important to us. It has to be two sides that are connected by an angle. It can't be side side angle or angle side side. That doesn't work. It has to be an angle or a side sandwiched by an angle. Right. So something like that, where I know I've got two triangles. So maybe I can draw. No, we'll see how accurate this is. That's not bad. Both of these things have the same angle and the same sides. And so as it turns out, if I'm going to connect and finish off as a triangle, okay, it also turns out that if I have side angle side, then it must be true that these angles are congruent to the corresponding angles, as well as that final side, the length of it has to be so, right? Because the length between those 2 points is not going to change if the angle doesn't change, and these side lengths don't change. So then I get that length, and the angle that it intersects with is going to change. So if I can prove side angle side, if I can prove, if I can spell side angle side, side angle side, I get triangle congruence. Right, so this is going to save us some time and maybe a little bit of pain. Okay, so let's look at an example of using side angle side to prove congruence. All right, so I have this shape right there. Goodness gracious. Right, and got that. The vertices are A, B, C, and D, and I'm told two things. The first is that BC is congruent to DA, and the second is that BC and DA are parallel lines. Right? Which is indicated by these arrows. Okay, so what I want to do is I want to prove side angle side between my triangle BCA and my other triangle DAC. Okay, I want to prove congruence, and I need side angle side. So I need two sides, and then I need an angle that connects those two sides. So we already have one side right off the jump. And so this is the first time, at least in a while, we're going to write a two-column proof. So a two-column proof has, I wrote that backwards, statements in one column, and then justification or reasons in the other. Right? So statements are things like this is congruent to that, and justification is the property that allows me to do that, or property or theorem, rather. So the first statement is always going to be my givens. Okay, so I'm given two things. First thing I'm given is that line segment BC is congruent to line segment DA, right? So all that means is that those two are congruent to each other. So maybe I should BC and DA, right? The second thing is that we know those two lines are parallel, right? So essentially that means if I were to extend them out, they would never meet or never cross. So I'll also write that out. BC is parallel. We just signal that with a parallel lines to DA, right? And both of those I got because they were given to me in the problem. So they may have been given to you as a statement. I gave them to you as a part of the diagram. Either way, we know they're both given. Right, so first step is always going to be the same. You're going to list out everything that you've been given. Now, this is the thing that makes this a little bit difficult is it's not, since we're not proving every single side and every single angle, we sort of have to pick which side or angles we can do. And I'm going to suggest in this case, it's easiest to pick a side. Okay, so I think that we should consider this side right in the middle here. Right? The reason is because both triangles share that side, so clearly it's the same length. Okay, so if it's the same length, then it's congruent, and you may or may not remember that property is called the reflexive property. Right? If I say that something is equal to itself, that's a reflexive property, specifically used when I say this line is equal or congruent to this other line. Right? So I can make the statement. One thing to mention, it may have been prudent of me to break this up into two separate triangles, but just know that B and D correspond, and then A corresponds to C and C corresponds to A, because that green triangle has sort of been rotated before I got stuck back on. So I'd want to say something like CA is congruent to AC. Okay, so I got a side there, I got a side there. I just need to get an angle that attaches those two sides, right? So I just need to get this angle right there. So we'll see if we can figure out a way to do that. Okay, but first, I've got my side length and I use the reflexive property, so I'm going to jot that down. Property. Okay. Now, getting the angle. This is going to be the tough part of the problem. So I want to prove, I guess I should have. Okay, I want to prove this angle right here is congruent to this angle right there. Now, what I'm thinking, I should use all of the information that I was given, and I haven't used that yet, that these two lines are parallel. Now, if these two lines are parallel, then this line right here is a transversal, right? And if that line is a transversal, then I've got parallel lines that are cut by a transversal, right? And if I've got parallel lines cut by a transversal, then that means that this angle and this angle are alternate interior angles, and I know, or at least I happen to know, that alternate interior angles are congruent to each other, so I can label that as congruent, right? And so, and I know that because I used alternate interior angles. As you can see, these properties that we've used in the past starting to pop back up. Okay, so I need to be careful with the way that I label this. Because C could be a few different angles, I want to label it using my using 3 different points. So B, C, A. Okay, C is that vertex, so it should be in the middle, and then a little angle piece, B, C, A. And I want for that angle to be congruent, which we've already proven. We came up with a reason, to D, AC. Okay, so that's this angle down here. A is the vertex, so we want that to be in the middle. So DAC. Oh my goodness gracious. DAC. And I proved that those two angles were congruent to each other using alternate interior angles theorem. Okay, so that was an angle. So if I go back up to my picture, I proved a side, I proved an angle and a side, and side, angle, side is congruent to each other. So because I've done that, then I have agreed that if I prove side, angle, side, then it gives me congruence. So I can make my final statement, which is these two triangles are congruent to each other. So, oh, that's not what I wanted. So I can say triangle BCA is congruent to triangle DAC. And why is it congruent? Well, I proved it using side, angle, side. So by side, angle, side. And that's it. Done. Square, Q, E, D. Okay, so that's one example. I want to mostly go over this in class. You've seen it now, but this is sort of a tough thing that we just need to practice and work through. A couple of takeaways, though, is that your first statement here should always be your givens, and your last statement should always be your final statement of what you're trying to prove. So I was trying to prove triangle congruence, and I did that, and why, right? What's happening in the middle here is I'm getting all of the pieces I need to prove, to prove side, angle, side down here, right? I need a side, I need my angle, and I need my side. So that's all to say. The first piece and the last piece should be pretty similar almost every time. So even if you have no clue what to do, you should always write down the givens and start labeling the diagram. Like I have here, I think labeling the diagram is usually the key to and getting down a nice 2-column proof. Even if you write down nothing in the 2-column proof and you do a nice labeled diagram, that can get you pretty far, right? So this is big key, big star, key, right? So we'll practice this some more in class. So wherever you're watching this video at, we will be practicing in class the next time I see you in class.